Hello everyone and welcome to 30 days of DSA challenge where we will be solving a DSA problem every day for the next 30 days. So this is our day number 21 and today we are going to solve a problem based on graph data structure and the level of this question is going to be medium. The name of this question is number of islands. You will get this question link in description and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on Leetcode. So here we are on Leetcode. Now let's read our question. So the question says, given an M cross N 2D binary grid, which represents a map of ones, land, and zeros, water, return the number of islands. So the question is saying, I have given you a 2D binary matrix, right? Or you can call it as grid as well. Now, what they mean by binary? Binary means they only have ones and zeros, okay? So question is saying, I have given you a 2D binary grid which only consists of ones and zeros, where ones represent lands, right? Ones represent lands and zeros represent water, right? Now you have to return the number of islands present in that particular binary grid, okay? Now you may ask this question, now what is this island, okay? So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So this line is very important. Here the question is explaining what they mean by island. So an island is formed by connecting adjacent lands and we can only connect lands either horizontally or vertically. Okay. You may assume that all the four edges of the grid are surrounded by water. What they mean by that? See, if we consider this grid, right? If we consider this grid, then this particular grid is surrounded by water from all the four sides. Okay. I hope it is clear to you. So firstly, let's try to understand the question by taking some sample test cases and then we will think of how we can solve this particular problem. Let's take this particular test case to understand our question. So in the question, it was clearly mentioned that 1 represent land and 0 represent water. Okay. And we have to count the number of islands. So before counting the number of islands, for us, it is very important to understand what they mean by island. Okay. So an island is a group of lands, okay? An island is nothing but a group of lands. But the lands are connected either horizontally or vertically. We can connect different lands either horizontally or vertically, right? So let's understand this. So let's consider this particular land, okay? Let's consider this particular land. So as per question, we can connect a land to its neighbor land, but only horizontally and vertically, okay? So I can connect this particular land with this land, right? Because this one is the neighbor of this particular land and it is in the horizontal direction, okay? Similarly, I can connect this land with this land because it is also the neighbor of this land and it is coming in horizontal direction, okay? And this one can also be connected with this one. This one can also be connected with this one, okay? Now, similarly, this one can be connected with this one because it is in the vertical direction and it is the neighbor as well, okay? This particular one, this land can be connected to this land, okay? And this land can be connected to this land as well. And if we consider this land, then it can connect it to this particular land as well, okay? Now, as per the definition, combination of lands make an island, okay? So now we can say that all the combination of these lands are making an island, right? This is nothing but a single island, okay? This is nothing but a single island. And we have to find out the number of islands by connecting the lands, right? Either horizontally or vertically. So I hope this is clear to you. Now let's come back to this sample test case, okay? Now if we consider this sample test case, then we can see that this particular one, we can connect it to this one, okay? Because it is in the horizontal direction. This particular one can be connected to this one because it is in the vertical direction. And this one can be connected to this one because it is in horizontal. And similarly, I can connect this one with the upper one as well, right? So you can see that all the lands are connected here either horizontally and vertically, and combinedly they are making an island, okay? So we can say that this is our first island, okay? Similarly, if I consider this particular land, so we can connect different lands either horizontally or vertically, okay? So if I see into this direction, I do not have something, right? I do not have anything either. And if I see in this particular direction, I have 0, and 0 means it is water, it is not land. So I cannot connect this one with this water, okay? Similarly, if I look in the upward direction, I have 0. It is also water, right? and in the downward I have nothing. Right? So this particular one, which is a land, in itself is an island. Okay, in itself is an island. So I can say that this is my second island. Correct? Similarly, if I consider this particular land, right, if I consider this particular one, then it in itself it is a single island. Okay, see, because I cannot connect it with this 0, I cannot connect it with this 0 as well, with this 0 as well, and with this 0 as well. Okay, so in itself this one is also an island. So this is our third island. Okay, and we have to return the number of islands. So the total number of islands present in this particular test case are 3. Okay, so 3 will be our answer. Correct? One thing which you need to keep into your mind is we cannot add two lands diagonally. Okay, let me just give you one example. Okay, so see, this is a land, this is a land, and this one is also a land. Okay, they both are neighbors, but I cannot connect them diagonally. Okay, connecting lands diagonally is not allowed. Okay, so this is not allowed. So I hope now the question is clear to you. Now let's think of how we can solve this particular problem. So before solving this particular problem, it is important for us to understand that this is a standard graph question. Now, if you are wondering how I got to know that this is a standard graph question, let me explain you. So see, in the particular grid, what do we have? We have different cells. Okay, this is my cell 1, this is one cell, this is one cell, and all the cells either have 1 or 0. Okay, so can we visualize these cells as nodes? Is it possible? Answer is yes, we can definitely visualize it. Okay, so let's say this is a node, this is also 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 a node, and this is also a node. Okay, now in order to solve this, what do we need? We need to connect adjacent lands. Okay, either horizontally or vertically. It means that I need to connect these two nodes. Okay, I need to connect these two nodes, I need to connect these two nodes, I need to connect these two nodes. Okay, now whenever in any particular question, if we can assume this thing that we need to connect different nodes, then we can understand that this is a standard graph question. Okay, so from here we can understand that this is a standard graph question. Okay, and in this particular graph question, what we have to do is we just need to count the number of connected components. Okay, now I hope you know what are connected components. So here we can clearly see that this is our one component. Okay, this is our one component, and this is our one component. So in total we have 3 number of components, and this is our answer, right? 3 are the number of islands and 3 are connected components. Okay, so this is what we have to do. So before solving, it was very important to recognize the problem. It was very important to recognize the pattern. Okay, so now as you know that this is a standard graph question and we need to count the number of connected components, so it means that we can solve this problem using 2 approaches. The very first one is the DFS or depth first search, and the second one is BFS or breadth first search. Okay, so in this particular video I will solve this problem using depth first search, and maybe in any other video we will solve using DFS. Okay, so I hope up to this point things are clear into your mind. Let's take this particular grid to understand how we are going to solve this problem. We know that in order to solve this problem, what do we need? We just need to count the number of connected components or the number of islands. So we can have a count variable which will be initialized with a value 0. So this count variable will tell us the number of connected components we have found so far. Apart from this, we will also have a visited 2D matrix, and the number of rows and columns in this visited matrix will be same as of our grid. Okay, and this visited matrix will tell us that a particular node or a particular cell in our grid is previously visited or not. Okay, so let's say that at any index inside our visited matrix, if we are having 0, it means that that particular node or that particular cell inside our grid is not visited. Okay, one more thing, in order to solve this problem, what we'll do, we will represent or we will assume that every index is a node. Okay, so we are assuming that every index is a node. Okay, so let's say that at any index inside our visited matrix, if we are having 1, this signifies that that particular node is previously visited. Okay, so I hope this is also clear to you. Okay, now in order to solve this problem, what we will do, we will do a normal traversal into our grid, and at every index we will check that do we have 1 in that particular index or not. Now why I am checking for 1? Because 1 is represented as land, okay, and in order to make islands we need to connect different lands, okay. So first thing which I will check is, do I have 1 at any particular index or not, okay. Second thing which I will check is that particular index or that particular node is previously visited or not, right. Now if these two conditions are satisfied, if both the conditions are satisfied, then I will make a DFS call with that particular node, okay. If you are confused with this, don't worry, as I'll do a dry run you will understand this in depth, okay. So let's say I started my traversal, okay. So the first index will be 0 comma 0, right. Now at the index 0 comma 0 I will check, do I have 1 at that particular index or not. So you can clearly see, yes, we have 1 at this index, okay. Now the second thing which I will check is this particular node or this particular cell is previously visited or not. To check this, I will take help of my visited matrix, right. So inside my visited matrix at the same index 0 comma 0, I will check, do I have 0 here or not. So yes, you can see that yes, I have 0. So this 0 signifies that this particular node is not visited previously. So both the two conditions are satisfied. Now if the both two conditions are satisfied, then what we will do, we will make a DFS call with the index 0 comma 0, okay. So we will make a DFS call with the index 0 comma 0, right. Now inside this DFS call, the very first thing which we will do is we will mark this index 0 comma 0 as visited inside our visited matrix, okay. So now at the index 0 comma 0, at the index 0 comma 0, I will write 1 here. So this 1 signifies that this particular node is already visited, okay. I hope this is clear to you. So now currently I am standing at a node 0 comma 0. So I know that in order to connect the lands, I can only move in 4 different directions, okay. Either I can go into the right side or into the left side. It means that I can move horizontally, or either I can go at the top or at the bottom. It means that I can move vertically, okay. So if I decide to go at the top, then what will be my index? My index will be -1 and 0. And if I decide to go at the left side, then my index will be 0 and -1, okay. So you can clearly see that here our index is a negative value, right? -1 and -1. And we do not have generally our index as a negative value. So you can say that this is invalid index. This is also an invalid index. So if we are encountering any invalid index, then what we'll do, we'll simply ignore it, right? We will ignore it. Okay. So now I am starting at 0 comma 0. So I will try to go at the right side, okay. Now if I decide to go at the right side, then my index will be 0 comma 1, okay. So now at this particular index, I will again check my two conditions. The very first one is it should have 1, okay. So here into our grid, you can clearly see that at the index 0 comma 1, we have 1, okay. So one condition is satisfied. Now what is our second condition? The second condition is this particular node 0 comma 1, it should be not visited previously, okay. So at the index 0 comma 1 inside our visited matrix, you can clearly see that we have 0. It means that we have not visited this particular node. If we have not visited this particular node and this node have 1, then we will make a DFS call with this particular node, okay. So we will again make a DFS call with the index 0 comma 1, okay. Now similarly, when I was standing at 0 comma 0, I could have also made a decision to go at the bottom, okay. And if I decide to go at the bottom, then my index will be 1 comma 0, correct. Now again I will check the two conditions at the index 1 comma 0, because this 1 comma 0 is a valid index, okay. So I will check at the index 1 comma 0, do I have 1 here? So you can clearly see that yes, I have 1 here. I will again check, is this 1 is previously visited or not? So inside my visited matrix at the index 1 comma 0, we have 0. So this signifies that this particular node or this particular cell is not previously visited. If it is not previously visited, then what I'll do, I'll make another DFS call with the index 1 comma 0. Now at the index 0 comma 0, we have tried to go in all the 4 directions, okay. So we have tried all the directions which were allowed to us, okay. So now this DFS call will get over, right? Now we do not have any further options, okay. So now we have two DFS calls, first with the index 0 and 1 and second with the index 1 and 0. So as we are doing a normal dry run, we can go with any one of them, but inside our code, when we will use a recursion to solve this problem, then what recursion will do, it will go with the DFS call which was made first. Okay, so this DFS call was made first. Okay, so recursion will go with this DFS call, and after returning back from this DFS call, recursion will go with this particular DFS call. Okay, but as we are doing a normal dry run, we can go with any one of them. Okay, we can go with any one of them. It is your choice. Okay, so let's say I decide to go with this particular DFS call. Okay, now inside this DFS call, the very first thing which I will do is I will mark this index 0, 1 as visited. Okay, so inside my visited matrix, I will come at the index 0, 1 and I will mark it as 1. So this 1 signifies that this particular node is visited. Okay, so now I am standing at the index 0, 1, right? Again, I have 4 directions to move. Either I can go at the right or at the left, at the top or at the bottom. So if I decide to go at the top, then my index will be -1 and 1, and you can clearly see that here we are having a negative value. We cannot have a negative value as our index. So this is an invalid index. If it is an invalid index, then we will simply ignore it. Okay, so if I decide to go into the left side, then my index will be 0, 0. Okay, so this is a valid index. The first thing which I'll check, do I have 1 at this particular index? You can clearly see that yes, I have 1. Second thing, I will check that this particular node or this particular index is previously visited or not. So inside our visited matrix at the index 0, 0, I have 1. So this 1 signifies that this particular node is already visited. If this is already visited, then I will not go at that particular node, okay, because it is already visited. If this is already visited, I will also ignore this, right? I will also ignore this. Now let's say I decide to go at the right side. Okay, so if I decide to go at the right side, then my index will be 0, 2. Okay, again I will check both the conditions. The very first one is at the index 0, 2, do I have 1 or not? So at the index 0, 2, you can clearly see that we have 0. Correct, we have 0. So we do not have 1. So this particular call will also not be made because we want 1. We want 1 at that particular node. Okay, so let's say I decide to go at the bottom, right? So at the bottom, my index will be 1, 1. Okay, so I will check the two conditions at this particular node, at this particular index 1, 1. Okay, so inside my grid at the index 1, 1, you can clearly see that I have 1. Okay, so the first condition is satisfied, right? Now the second condition is this particular node should not be visited previously. Correct. So now I will come inside my visited matrix, and at the index 1, 1, I will check, do I have 0 here? So you can clearly see that yes, I have 0 here. If I have 0, this means that this particular node is not visited previously. Correct. So both the conditions are satisfied. This particular node have 1 and this particular node is also not previously visited. So what we will do, we will make a DFS call with this particular index with 1, 1. Okay, and for this particular index 0, 0, we have tried to go in all the 4 directions. So right now our call for this particular node will be over. Okay, so now we are standing at this particular DFS, right? At this particular DFS with the index 1 and 1. So inside this DFS call, the very first thing which we'll do is we will mark this index as visited inside our visited matrix. Okay, so now we will come at the index 1, 1 inside our visited matrix and we will mark it as 1. So this 1 signifies that this particular node or this particular cell is already visited. Okay, so now I am standing at the index 1, 1. Okay, again I can go in all the 4 directions. Okay, so let's say if I decide to go at the top, then what will be my index? My index will be 0, 1. Okay, so again I will check for the two conditions. Do I have 1 at this particular index? You can clearly see that yes, I have 1. The second condition is this particular node is previously visited or not. So you can see that at this particular index inside our visited matrix we have 1. So this 1 signifies that it is already visited. If it is already visited, I will not go at that particular node. Okay, I will not make any DFS call with that particular node. Okay, so now at the index 1, 1, if I decide to go in the left side, then what will be my index? My index will be 1, 0, right? My index will be 1, 0. So now I will again check both the conditions for this particular index 1, 0. Okay, the very first one is at this index 1, 0, I should have 1. So you can clearly see that yes, I have 1 at this particular index. Second thing I will check inside my visited matrix at this particular index, I should have 0. Okay, So you can clearly see that yes, I have 0. It means that this particular node is not previously visited. If this is not previously visited, then what we will do, we will make a DFS call with this particular node. Okay, so we will make a DFS call with the index 1 comma 0. Okay, now let's say I decide to go in the right side. Okay, so if I decide to go into the right side, then my index will be 1 comma 0. So I will check both the conditions at this particular index as well, because this is a valid index. Okay, firstly we have to check that the index is valid or not. If it is valid, then we will check our two conditions. Okay, so we'll come at the index 1 comma 2. This is our index, right? This is our cell with the index 1 comma 2. So we'll check, do I have 1 here or not? So you can clearly see that we have 0. And if we are having a 0, we cannot add that particular water into our island, because we can only add lands into our island. Okay, so we'll not go with this particular node as well. Okay, so if I decide to go at the bottom, then the index will be 2 comma 1. Okay, so now here this is the index 2 comma 1. Okay, so again I will check, do I have 1 at this particular index or not? So you can clearly see that we have 0. Correct. And if you are having a 0, I cannot add it into my island. Okay, so I will also not make any DFS call with this particular index as well. Okay, so for this particular index 1 comma 1, we have tried to cover all the 4 directions. Okay, so now this DFS call will get over, right? It will get over, right? So now we will come at this particular DFS call with the index 1 comma 0. So the very first thing which we will do is we will mark this index as visited inside our visited matrix. So we will come at the index 1 comma 0 and we will write 1 here. So this 1 signifies that this particular node is now visited. Okay, so now I am standing at a index 1 comma 0. Okay, again I can go in all the 4 directions. Okay, so if I decide to go at the top, then my index will be 0 comma 0. Okay, and you can clearly see that inside my visited matrix I have 1 at the index 0 comma 0, right? It means that this is already visited. If this is already visited, it means that I cannot go in that particular node. Okay, I cannot go in that particular node, so I'll not make any DFS call for this particular index. Okay, so if I decide to go into the left side, then my index will be 1 and minus 1. So you can clearly see that we are having a minus 1, or we are having a negative value as our index. So this is an invalid index. If it is an invalid index, we will not make any DFS call with that particular index as well. Okay, now if I decide to go into the right side, then my index will be 1 comma 1. And you can clearly see the index 1 comma 1 is already visited, right? We are having 1 at the index 1 comma 1 inside our visited matrix. It means that it is already visited. So if it is visited, we will not make any DFS call. Okay, again let's say I decide to go at the bottom, then my index will be 2 comma 0. Okay, so now at the index 2 comma 0, I will check, do I have 1 here? You can clearly see no, I have 0. If I have 0, I cannot make a DFS call with this particular index, so this particular index will also get ignored. Okay, so now for this particular index 1 comma 0, we have tried to go in all the 4 directions. So now this particular DFS call is also over. If this is over, then we will return back to the previous DFS call. Okay, we will return back to the previous DFS call with a value 1 comma 1. And this particular DFS call is also over. So we will move to the previous DFS call with the index 1, with the index 0 comma 1. Okay, so right now we are standing at this particular DFS call with the index 0 comma 1. Okay, so this particular DFS call is also over. Then what we'll do, we'll go to the parent, which is this, right? Which is DFS of 0 comma 0. So now we are standing at the DFS of 0 comma 0. So this left side of DFS call is already visited. The left side is already visited, right? The left side is already done. So now what we will do, we will go at this particular DFS call, right? At the index 1 comma 0, correct? So let's say I'm standing at the index 1 comma 0. I can go in all the 4 directions, correct? Now if I try to go at the top, then my index will be 0 comma 0, and you can clearly see that this particular index is already visited. So I will not make any DFS call with this particular index. If I decide to go into the left side, then my index will be 1 and minus 1, which is an invalid index. So this will also not be considered. If I decide to go into the right side, then my index will be 1 comma 1. But inside our visited matrix, you can clearly see that this particular index is already visited. So we will not make any DFS call with this particular index as well. Okay, and if I decide to go at the bottom, then my index will be 2 comma 0, and at the index 2 comma 0 I have 0. So I will also not make any DFS call with this particular index as well. So for this particular index 1,0, we have tried to go in all the 4 directions. So this particular DFS call is also over. Okay. So now from this particular DFS call, we will move back to the parent. Okay. We will move back to this particular DFS call with the value 0,0. So this particular DFS call 0,0 is also completely executed. So now what we'll do, we'll return back. We will return back, right? So now when we are returning back from this DFS call, if you clearly see, we have made this visited, right? We have marked this 4 cells as visited, right? This 4 cells I have marked as visited. And if you see clearly that these 4 cells are combining together to make an island, okay? So therefore, whenever we will return back from our DFS call, we will increment our count, correct? We will increment our count. So now my count will be equal to 1, right? And this is our island, okay? This is our island, or you can say that this is our corrected component. So I hope it is clear to you. Now let's move forward into our dry run. So if you have remembered what we were doing a normal traversal inside our grid, and we were checking the 2 conditions. The first one is that particular node or that particular index should have 1, and that particular node should not be visited. Okay, so we have checked the conditions for this particular index 0,0. So now we'll move at the index 0,1. Okay, again we'll check the 2 conditions. Do I have 1 here? You can clearly see that yes, I have 1 here. Second condition I will check, is this particular cell is previously not visited or not. Okay, so you can clearly see that we have 1 at this particular index inside my visited matrix. It means that this is already visited. If this is already visited, I cannot make a DFS call, right? I cannot make a DFS call. So I will go with the next index. So the next index is 0,2. At this particular index, I will check. Do I have 1 here? You can clearly see that I have 0. So I cannot make a DFS call. Again, I'll go at the next index, which is 0,3. Do I have 1 here? You can see that I have 0. So I will not make any DFS call. Okay. I will come at the next index, which is 1,0, right? So at this particular index, I will check. Do I have 1 here? So the answer is yes, I have 1. Second condition is, this particular index is previously visited or not? You can clearly see that it is already visited. If this is already visited, I cannot make a DFS call. So this particular node will also get ignored. Okay. So now we'll come at this particular index 1,1. Again, I will check for the 2 conditions. Is this node have value 1? You can clearly see that yes, it have value 1. Second thing is it previously visited or not? You can clearly see that this is previously visited. If this is previously visited, it means that I cannot go with this particular node. Okay. So we will ignore this, right? Then we'll go at the next index, which is 1,2. At this particular index also, I will check the 2 conditions. The first condition is, do I have 1 here or not? You can clearly see that I have 0. If I have 0, I cannot make a DFS call. I will go at the next index, which is 1,3. Again, I will check. Do I have 1 here? You can see that no, I have 0. I will ignore this. I will go at the next index, which is 2,0. So at the index 2,0, I will check. Do I have 1 here? The answer is no, I have 0. I will go at the next index. At the index 2,1. Do I have 1 here? No, I have 0. Again, I'll go at the next index, which is 2,2. Now, at the index 2,2, I will check. Do I have 1 here? So you can clearly see that yes, I have 1. Okay. Second condition is, this particular node is previously visited or not. So inside my visited matrix, at the index 0, at the index 2,2, you can clearly see that we have 0. So this 0 signifies that this particular node is not previously visited. If this is not previously visited and this particular node have value 1, then we can make a DFS call. Okay. So what we'll do, we will make a DFS call with the index 2,2. Now inside this DFS call, the very first thing which I'll do is I will mark this particular index as visited. Okay. So I will come inside my visited matrix, and at the index 2,2, I will mark it as 1, right? I will mark it as visited. Okay. So right now I am standing at the index 2,2. Okay. So I can go in all the 4 directions. Okay. So if I decide to go at the top, then the index will be 1,2, and at the index 1,2, you can see that we have 0. We have 0. So I cannot, it is not land. If it is not land, I cannot add it into my island. Okay. So we will ignore this particular index as well, right? Now, if I decide to go into the right side, then my index will be 2,3. Okay. So now at the index 2,3, you can clearly see that we have 0. So I cannot add this into my island as well. So this will also get ignored. If I decide to go at the bottom, then my index will be 3,2. So at the index 3 comma 2, you can clearly see that we have 0. It means that I cannot also add this into my island, so this will also get ignored. Correct. Similarly, if I decide to go into the left side, then my index will be 2 comma 1, and at the index 2 comma 1, you can clearly see that we have 0. If you are having a 0, it means that I cannot add it into my island, I cannot add it into my component. Okay, so this will also get ignored, right? So for this DFS call with the index 2 comma 2, we have tried to go in all the 4 directions. So right now this particular DFS call is over, right? This particular DFS call is over. Then what we will do, we will return back. So from this DFS call, we will return back. Okay. And remember, whenever we are coming back from a DFS call, what we'll do, we will increment our count. Why we are incrementing our count? Because this one is in itself a component. In itself, it is making an island. Okay. Therefore, we will increment our count. So now my count will be equal to 2. Okay. I hope this is also clear to you, right? So again, we will continue our traversal. Okay. So now I will check at the index 2 comma 3. Do I have 1 here? So no, I have 0. I will ignore it. At the index 3 comma 0. Do I have 1 here? No, I have 0. I will check at the index 3 comma 1. Do I have 1 here? No, I have 0. At this particular index 3 comma 2, I will check. Do I have 1 here? No, I have 0. So now at this particular index 3 comma 3, I will check. Do I have 1 here? So the answer is yes. Yes, I have 1 here. The second condition is this particular node is previously not visited. So I will come at the visited matrix, and at the index 3 comma 3, I will check. Do I have 0? Yes, I have 0. So if I have 0, it means that this particular node is not previously visited. If this particular node is not previously visited and this particular node have value 1, I will make a DFS call with the index 3 comma 3. Okay. Now inside this DFS call, the very first thing which I'll do is I will mark this particular node as visited. So I will come inside my visited matrix, and at the index 3 comma 3, I will write 1. So this 1 signifies that this particular node is now visited. Okay. So now I am standing at the index 3 comma 3. I have 4 directions to move. Okay. Now if I decide to go into the right side, then my index will be 3 comma 4. Okay. But inside my grid, you can clearly see that I do not have any index 3 comma 4. Okay. So this is invalid. So we will ignore this. Okay. Similarly, if I decide to go into the bottom, at the bottom side, then my index will be 4 comma 3. So here you can see that we do not have any index with 4 comma 3. Okay. So this is out of bound. So we will also ignore this particular index. Okay. Now if I decide to go at the top, then my index will be 2 comma 3. Okay. So I will again check inside my grid at this particular index 2 comma 3. Do I have 1 or not? So you can clearly see that I have 0. If I have 0, I will ignore this. Okay. So now if I decide to go into the left direction, then what will be my index? My index will be 3 comma 2. So at the index 3 comma 2, you can clearly see that I have 0. If I have 0, it means that I cannot make any DFS call, right? So for this particular DFS call, for this particular index 3 comma 3, we have decided to move in all the 4 directions. Okay. So now this particular DFS call will get over, right? This particular DFS call will get over, and we will return back. Whenever we are returning back from a DFS call, what we'll do, we will increment our count. Okay. So now my count will be equal to 3. Okay. I hope this is clear to you. Okay. And after this, if I again try to do my traversal, so this was my last node. Okay. So my traversal will get ended here, and we have ended with the count equal to 3. It means that inside this grid, we have 3 islands, or we have 3 connected components. Okay. The very first connected component is this. Okay. It is this particular component, right? This particular component. And the second one is this particular component. Okay. This particular component. And the third one is this particular component. Okay. This particular component. So I hope it is clear to you, right? If you have some doubts, then make sure that you do some dry runs from your own, so that you will understand this in more depth. And in order to understand this problem, it is important that you should know what is DFS. Okay. What is components, right? So you should know all these stuffs in order to understand this. I hope you know this. So now I have shown you a very in-depth, in detailed dry run. So now we will move into the coding side. So before going to the coding part, one thing which I want to explain you, let's say if I'm standing at an index 2 comma 2. Okay. So I can move in 4 directions. Okay. Either I can go at the top, I can go at the bottom, I can go in the right side, or I can move into the left side. Okay. So if we try to write all the 4 indexes of these 4 directions, then at the top, the index will be 1 comma 2. Okay, if I decide to move into the right, then the index will be 2 comma 3. If I decide to move at the bottom, then my index will be 3 comma 2. If I decide to move into the left side, then my index will be 2 comma 1. Okay, and now if you clearly see, so whenever we are moving at the top, what we are doing, see, if I consider this value as x and this value as y, okay, so here the value of x was 2, but when I went at top, then the value of x became 1. What does it mean? We have done a -1 here, right? -1. And the value of y is 2 here, and the value of y is also 2 here. It means that we have added 0. Okay. Similarly, if I decide to go at the right side, then the value of x is same. Here also it is 2, here also it is 2. So you can say that we have added 0. Okay. But the value of y is 2 here, and the value of y is 3 here. You can say that we have added 1 here, right? We have added 1 here. Similarly, if we are going at the bottom, then the value of x was 2, but now the value of x is 3. It means that we have added 1 here, right? Similarly, the value of y was 2 and the value of y is also 2 here. It means that we have added 0, correct? Similarly, if I'm going into the left direction, then the value of x is same, right? Here also we have 2, here also we have 2, okay? So you can say that I have added 0 into my x, okay? Now, if I take the value of y, then here the value of y was 2, but here the value of y is 0. So you can say that we have added -1, okay? So if you can see this, if you observe this, what we are doing in all the 4 directions, either we are adding -1 or 0, or we are adding 0 plus 1, or +1 or 0, or 0 or -1. Okay, so see, if I just try to write the value of x, okay, the value of x. So firstly, the value of x was -1, okay, so I can write -1 here. Then the value of x is 0, so I can write 0 here. Then the value of x is +1, right? So I can write +1 here. Then the value of x is 0, so I can write 0 here, right? Let's say that this is my array, right? This is an array, okay? So if I now write the value of y, then firstly the value of y was 0, so I will write 0 here. Then the value of y is +1, right? Then I will write +1 here. Then the value of y is 0, so I will write 0 here. Then the value of y is -1, then I will write -1 here, right? And this is nothing, this x and y is nothing but our array, right? This x and y is nothing but our array. And now what we can do with the help of this x and y array, we can move in all the 4 directions. Let's say I'm standing at the index 2 comma 2, okay? So now if I add, let me just write the indexes here first, 0, 1, 2. So if I add the index 0 of x into this 2, right, then the value will become 1, okay? If I add the value of y at the index 0 into this particular 2, then the value will become 0, and this is nothing but our top index, right? Similarly, if I want to go in the right direction, what I'll do, in this 2 I will add the value 0, okay? So the value will remain 2, correct? In this particular 2, in the value of y, what I'll do, I'll add the value +1, so the value will become 3, okay? This is nothing but our right index. Similarly, if I try to go at the bottom, then what I have to do in this particular 2, if I add the value of x at the index of 2, the value is 1, okay? So 2 plus 1 is 3, okay? Similarly, for this particular 2, which is nothing but the value of y, if I add 0, then the value will become 2, right? So this 3 and 2 is nothing but our bottom index, right? Similarly, if I try to go into the left side, so for going into the left side, what just I just need to add this 0 into the x value. So the x value is 2. 2 plus 0 is 2. And similarly, if I decide to go into the left side, okay, so in this particular 2, I need to add the value -1, right? So if I add -1, then the value will become 1, okay? And this is nothing but the index of our left side, okay? So these are our arrays which we will use to move in all the 4 directions, okay? We are going to use this particular array of x and array of y, okay? So I hope this is clear to you. If you are having problem, please do some dry runs. You will understand this in more depth, right? We are just using this array to make our traversal in all the 4 directions easy, okay? I hope that you will understand this, right? So now let's quickly move to Leetcode to code this problem. So now we are here on Leetcode. So let's fastly code the approach which we have just discussed. So very firstly, we need to know what are the number of rows and what are the number of columns into our grid. So therefore, we will write int m is equal to grid dot size. This is nothing but the number of rows, and for number of columns, we will write int m is equal to grid of 0 dot size. Okay, and we also need a counter or a count variable which will be initialized with the value 0, and we also need a 2D matrix, right, known as visited, right. It will be of the same rows and columns, right. So the number of columns, sorry, the number of rows will be n, and the number of columns will be m, and it will be initialized with the value 0. Okay, and at the end we will be returning our count variable. Okay, so here what we'll do now, we will do a normal traversal. So I think you know that if we want to do a normal traversal into 2D matrix, we will take help of two for loops. Okay, so here I will write int I is equal to 0 and I is lesser than n I plus plus, and inside this for loop I'll write int j is equal to 0, j is lesser than m, and j plus plus. Okay, so inside this I need to check the two conditions. So the very first one is the grid of I and j should be equal to 1. Okay, so now why I am writing this one in a single quote? The answer is we are receiving a 2D grid of characters type, right? Therefore I have written this one in a form of character. Okay, so if we are having one, then the second condition is that it should not be visited, right? It should not be visited. So I can write it with this, the visited of I and j should be equal to 0, correct? Now, if both the two conditions are satisfied, then we can make our DFS call with the indexes I and j. But apart from I and j, we will also send some other information like the value of n, the value of m, our grid, and our visited matrix as well. Why I am sending all these values? Because we need them in order to write our DFS code. Okay, when we will write our DFS code, you will understand this. So when we will come back from our DFS call, what do we need? We need to increment the value of count. Okay, so therefore I have written count plus. So now we just need to implement our DFS, right? So here, let me write the code for our DFS. So we know that we do not need to return anything from our DFS, right? So we'll write void DFS, and here I will receive all the values. Okay, so here I will write int row and int column. So this row and column is nothing but the indexes, right? I and j. Okay, and then I will receive int n, int m, and I will also receive my vector of chars. I will pass it by reference grid. Okay, and apart from this grid I will also receive my visited matrix. Okay, so the type of my visited matrix is vector of int. I will pass it by reference as well. Okay, so I hope this is clear to you. So what's the first step we need to do inside our DFS? The very first step is we need to mark it as visited. Okay, so I will write int row and column is equal to 1, right? So after marking it as visited, we will go in all the four directions. So in order to go in all the four directions, we will use two arrays. Okay, the very first one is the x. Okay, what will be the values? The values will be -1, 0, +1, and 0. Okay, similarly we also need a array y, and here also the indexes will be 0, +1, 0, and -1. Okay, I hope this is clear to you. Then we will simply write a for loop. Int I is equal to 0, I is lesser than 4, I plus plus. Okay, so now we just need to do a normal traversal inside these two arrays in order to go in all the four directions. Okay, so the value of the new row, okay, or the new index will be equal to row plus x of I, and the value for our new column, right? The value for our new column will be equal to col plus y of I. Okay, I hope it is clear to you. So now firstly we need to check that these two indexes are valid or not. So how we can check this? Here we will write the value of new row should be greater than or equal to 0, and the value of new row should be lesser than n. Okay, similarly we need to write these two conditions for our new column as well. The value of new column should be greater than or equal to 0, and the value of new column should be lesser than m. Okay, now if both these two conditions are satisfied, that means the index is valid, right? Now if the index is valid, then we need to check for the other two conditions, right? The other two conditions are inside our grid at this particular index we should have value 1. Okay, we should have value 1, so it should be equal to 1, and Secondly, it should not be visited, right? So here I need to write visited of new row and new column should be equal to 0, right? Now if these all conditions are satisfied, it means that now I can make a DFS call with this particular index, right? So I will make another DFS call with the index new row and new column. Okay, apart from this I will also send other informations such as n, m, my grid and my visited matrix. Okay, so this is the code for our DFS, and this is the complete code for our number of islands problem. So let me run this. So here we are getting a compilation error at the line number 15. We can see that I have written 3 ampersand sign, so it will be only 2. Now let me run this. So we have one more compilation error at line number 16, use of undeclared identifier grid. Why so? I think I made a spelling mistake. Yeah, here I have made a spelling mistake. It will be GRID. Now let me run this, and now it should run fine. Okay, so here you can clearly see that all the 2 sample test cases are running fine. Let me submit this. So here you can clearly see that this particular code is also accepted. So I hope this video was helpful to you, but we haven't discussed the time and space complexity. So now let's discuss the space complexity for our code. So what we were doing, we were using a visited matrix, and the number of rows and columns into our visited matrix is equal to our grid. Okay, and the number of rows and columns into our grid were n and m. So the space complexity will be n cross m, right? Apart from this visited matrix, we were also using 2 array x and y, and the size of these 2 arrays were equal to 4. Okay, so this 4 is nothing but a constant value. Okay, so therefore we will not consider it. Okay, so now if we talk about the time complexity, then inside our code what we are doing, we were having 2 for loops. Okay, 2 nested for loops, and inside these 2 nested for loops we were making call to our DFS function. Okay, and the first for loop were running from 0 to n, and the second for loop was running from 0 to m. Okay, so the time complexity for these 2 nested for loops will be equal to big O of n cross m. Okay, and inside this, if the condition is satisfied, right, we were written some condition here. So inside if the conditions were satisfied, then we were making this DFS call. So you should know that the average time complexity for any DFS call is equal to big O of v plus e. Okay, where this v is nothing but the total number of nodes, and this e is nothing but the total number of edges. Okay, what are the total number of nodes? The total number of nodes are nothing but n into m, right? N into m, because in our grid we have n into m cells, and we have assumed that each cell is a node, right? Therefore the total number of nodes will be n cross m, right? And if we talk about the total number of edges, so let's say that this is our node. So at max, how many edges it can have, right? It can have this much edges, right? It can have total of 8 number of edges, correct? So we can see that the number of edges will be 8 into the number of nodes. So the number of nodes is nothing but n cross m, right? So if I try to simplify the time complexity for this DFS, so it is nothing but big O. It is nothing but big O of v plus e. So the value of v is nothing but n cross m, and the value of e is nothing but 8 into n cross m. Okay, so if I try to write the approximate version, so you know that this is a constant value 8, correct? So we can ignore it, and they both are written into addition, right? So we can just directly write it big O of n cross m. Okay, so this is our final time complexity, correct? And this is our final space complexity. So I hope this particular video was helpful to you. If it was, then make sure that you like to this video, you subscribe to this channel, and don't forget to drop a comment. We will meet again tomorrow with a new question.